In this screen capture, I will focus just on this idea of simultaneity. We know that two observers will always measure the speed of light to be the same value, whatever speed or velocity they're going at. Another point is that if the speed of light is going to be the same, if they're going to measure the same value for the speed of light, they will not necessarily agree on distance or time, and this brings us the idea of simultaneity. We can watch this video which is about simultaneity, which is an excellent illustration.
Imagine two observers, one seated in the center of a speeding train car, and another standing on the platform as the train races by. As the center of the car passes the observer on the platform, he sees two bolts of lightning strike the car, one on the front and one on the rear. The flashes of light from each strike reach him at the same time, so he concludes that the bolts were simultaneous, since he knows that the light from both strikes traveled the same distance to his eyes at the same speed, the speed of light. He also predicts that his friend on the train will notice the front strike before the rear strike, because from his perspective on the platform, the train is moving to meet the flash at the front and moving away from the flash at the rear. But what does the passenger see? As her friend on the platform predicted, the passenger does notice the flash from the front before the flash from the rear, but her conclusion is very different. As Einstein showed, the speed of the flashes as measured in the reference frame of the train must also be the speed of light. So, because each light pulse travels the same distance from each end of the train to the passenger, she can only conclude one thing. If she sees the front strike first, it actually happened first. Whose interpretation is correct? The observer on the platform, who claims that the strikes happened simultaneously, or the observer on the train, who claims that the front strike happened before the rear strike? Einstein tells us that both are correct, within their own frame of reference. This is a fundamental result of special relativity. From different reference frames, there can never be agreement on the simultaneity of events.
From different reference frames, there cannot be agreement on the simultaneity of events. We know that light is constant for all observers independent of the frame of reference. In this example, you saw that the observer on the platform sees both strikes at the same time. So, to them, the two events were simultaneous. We know it happened simultaneous. He can work out that it's simultaneous because it's exactly the same distance from each strike, and he sees them at the same time, so therefore they must have occurred at the same time, because the speed of light means that they travel the same distance in the same time. However, the observer on the train, she sees the front strike before the rear strike, because she's moving towards the front strike. So, as far as she is concerned, she is the same distance from both strikes. She sees the first strike first to travel the same distance. Therefore, the first strike must have happened on the front of the train first. So the front strike happened first. The train is moving towards the front strike according to the platform observer. This means that two observers in different inertial frames of reference will not agree on simultaneity. Only if, however, the events that happen in different places. If they happen in the same event, same place, two events in the same place, then they must be simultaneous for everybody. Who is correct? Is it the person on the side on the platform that sees the events as being simultaneous? Is it the person on the train that sees the front strike as being before the last strike? Well, from their point of view, from their frame of reference, both are correct. And here we have again. The observer on the platform flashes are simultaneous, so they see this one and this one strike at the same time. This distance is the same, it takes the same amount of time, so the flashes happen at the same time. What about the observer on the train? Now we know that light is constant for everybody. What happens here is the train is moving towards the front since the train is moving forwards towards the front strike first, they will see the front strike first. The front strike before the back strike. So basically, since the person on the train measures the distance as being the same, and this one happens first, in other words with less time, it means that this one happens first, the front strike is first, the back strike is afterwards. So B happened first, the front strike, according to the observer on the train, because it travels the same distance. What happens if the observer on the train sees the flashes simultaneously? What will the observer on the platform observe? Well, the observer on the train, let's say, sees both strikes at the same time. What about the observer on the land? Well, since the light is constant for all observers independent of frame of reference, we know the train is moving from A, moving to the right. Okay, so the only way that these two flashes could arrive from the point of view of the person on the platform, the only way they could arrive at M at the same point in time, is that since the train is moving to the right, the light has further to go from A than it does to B. The light has further to go from A than it has to B. And since A is moving in this direction, A must have happened first because there's a further distance to go. And this is a further distance. So as far as the observer on the platform is concerned, the strike at A happens before the strike at B. In other words, it strikes the back of the train before the front of the train. To summarize, a Galilean transformation. This is a calculation of events in a moving frame of reference, where we take classical mechanical calculation, where length, distance and time are absolute. This is pre-relativity. An inertial frame of reference. This is a set of axes in which you take measurements and so on, which is not accelerating. The postulates. The laws of physics are same for all observers in all inertial frames of reference. And also the main thing is the speed of light in a vacuum is constant for all observers in all inertial frames of reference. I underlined in a vacuum. In one of the mark schemes they insisted that you put in a vacuum. Simultaneity. No two observers in differing frames of reference can agree on the simultaneity of events in different places. For example, the train moves towards the light source. The observer sees one flash first, and since the distance is same and c is constant, the time must be less, therefore flash 1 must have happened first. There is no absolute frame of reference. This is a conclusion here. Who is the correct? Both are correct because there's no absolute frame of reference.